and gentlemen, this is the start of our flipped classroom. We are doing chapter 3, talking about types of equations. Linear will be the first start here. So as you can see on your guys' screen, we have linear equations. Big question of the day is, what are the characteristics of a linear and a nonlinear equation? And we have some vocabulary words for you to write down. I will talk about those very, very quickly so that you don't have to worry about going through them and having me waste your time here. Linear means it makes a line. Constants are just regular numbers. Regular numbers, such as in standard form here, the letter C. You guys know that x and y are variables. A and b are then the coefficient, the number that the x or the y is being multiplied by. So it's super important that we have that information understood, that standard form must be in the form of ax plus by equals c. Now over here, it's important you guys understand that a must be greater than or equal to 0, which means we cannot have fractions and we cannot have negative numbers for our a. So that's important for us when we are trying to determine if something can be written into standard form and how to make it officially into standard form. Alright, let's keep it cruising. So our job for these first examples is to determine if the equation is linear and then write it in a standard form. So up here is our first example. We have a 5x plus a 3y equals a z plus 2. Now I'm going to tell you right away, folks, there's a problem with this equation, and it's that letter z. Z is not in ax plus by equals c. So therefore, this is going to screw up our problem, because we would subtract z from both sides to get it into the x's, the y's by themselves, and the c also being by itself on the equal sign. And this changes it to be a 5x plus 3y minus a z, and that does not equal to a 2 in standard form. So let's keep on cruising. Alright, here we are. Next one, y equals 4 minus 5x. So in standard form, we want to have all our x's and our y's on the same side, and we're going to then bring this minus 5x over, so we add 5x to both sides. That gets us to 5x plus a y equals a 4. This is in standard form, and it is linear because it is in standard form. Example 3, we have a 3/4. We cannot have our x coefficient be less than 1. 3/4 is less than 1. So we need to get rid of this fraction. So what we're going to do is we're going to multiply everything. I'll change colors. Multiply everything by a 4. When we multiply everything by a 4, it's the common denominator. Now we have 3x minus 4y equals 32, and we have turned this into standard form. We cannot have fractions for it to be in standard form. So this is also a linear equation. Example 4, we have an exponent. Nope, that doesn't work. We can't have exponents for us to be into standard form. So that one is nonlinear. Keep moving. Intercepts. It's super, super important when we learn how to graph that we know things about our x and our y intercepts. Where a line crosses the y-intercept, x is equal to 0. So this is our y-intercept, where x equals 0. That's important that you understand that x equals 0 for your y-intercept. It's the exact same thing over here for my x-axis, which goes left to right. Where the line crosses the x-axis, y is equal to 0. And again, that's where it crosses the x, so it's called the x-intercept. So we need to understand that when we have an x-intercept, y equals 0. When we have a y-intercept, x equals 0. This horizontal line right here is going to say y is equal to 1, 2, because y is 2 along this whole line, And over here where x is equal to 1, that is our vertical line. So we understand that horizontal lines where it says y equals just a number, and vertical lines are where it says x equals just a number. All right, so what do we do with this kind of information? Well, we have word problems in the real world. A box of peanuts is poured into a bag at the rate of 4 ounces per second. The table shows the function relating to the weight of the peanuts in the box and the time in seconds that it takes for us to pour out of the box. So we have all of this information, this chart, and we're going to graph it so that we can figure out the x and y intercepts. I'm going to use these variables. Over here we have an x and then a y. So at 0 seconds we're at 2000, so which is right here. Put a point at, oopsies, that's got to be right, no, that was good right there. Let me erase to make this look better. Alright, now we're good again. So at 0 seconds, right here, we have 2,000 ounces. At 125 seconds, which is right here, we have 1,500. At 250 seconds, we're at 1,000. At 375, we're at 500. So that's down below here. And at 500, we're at 0. Okay, so what does this tell us? The x-intercept is where it crosses the x-axis, which is going left and right here. The y-intercept is right here. So if we imagine that the graph would be continued on, so that you guys can see all of your coordinates. So the line would go like that. So this is just quadrant number 1 over here. My x-intercept is when y is equal to 0. So my x-intercept has the point of where y is equal to 0 of 500, comma 0. My y-intercept is when x is equal to 0, and that happens right here. So my two intercepts. My y-intercept is x is equal to 0, so my x is a 0, my y was 2,000. Now what does this truly mean in part B? Well, the x-intercept, way down here, that's when there's no more peanuts left in the box. You've poured everything out of the box. The y-intercept tells us how much does it weigh before we've even started to pour things out. So if you imagine I had this cup here with chips in it, I just ate a chip, so there's less weight. So if I were to pour it out, I would finally be at completely empty over here. Where I began was up here. Those are good chips. All right, so we can use this information to help us graph other types of problems. So if we have something in standard form, we can use that information. So to find the x-intercept, we say y is 0. So in for the equation, we have 4x minus 0 equals 4. I don't even think about the 0. So I divide by 4, and x is equal to 1. So if x equals 1 and y equals 0, that's a point that I can graph. So to the right 1, up 0. That's a point. Okay, let's keep going. To find the y-intercept, we say x equals 0. So back into the exact same equation. 4 times 0 minus a y is equal to 4. So that equals 0. If a negative y equals 4, so we divide by a negative 1 to make this a positive y. So y is equal to a negative 4. So if y is negative 4, x is 0, and we can graph that. So that means we just go down 1, 2, 3, 4, and then all I have to do is connect the dots. Okay? This is how you graph using the intercepts. So let's try another one. We'll be really quick here. X equals x-intercept, y equals 0. So into my coordinates I have a 0, and y equals 0. So 0 is equal to 2x plus 2 minus 2 minus 2, which means that 2x equals a negative 2, which means that x is equal to a negative 1. So we graph that. Minus 1, 0, boom, that's a new point. Let's go to the next one. Find the y-intercept. That means x equals to 0. So y is equal to 2 times 0 plus 2. Well, that's nothing. So y is equal to 2. And x is equal to 0. So we graph that point, 0, 2. And I can connect the dots, la, 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 la. All right. So that's pretty easy stuff, right? The other process that we can use for graphing is to make a table. So we just plug the numbers in. So I plug in negative 2, negative 1, 0, 1, and 2 just because those are numbers, they're going to be the smallest 5 numbers that I can choose. And I just plug them in. 2 times a negative 2 minus a y equals 2. I do the math. This is a negative 4. Negative 4 minus y equals 2. So I add 4, and a negative y equals 6. So that means that y is equal to a negative 6. So I have a negative 6 ordered pair of negative 2 comma negative 6. The process here, folks, is to pick negative 2, 1, negative 1, 0, 1, and 2, plug them into the equation, and find out what y equals so that you have an ordered pair. That means we now have the ordered pair of a negative 2, negative 6. We go to the left, 1, 2, we go down 6. 1, 2, 3, 4, 5, 6, and I make a point. And I do the exact same process over and over again. I don't think we need to probably show you that stuff because it's that simple. So this is Berman, Bermanation, your teacher, signing off. Your assignment is on my calendar.